Welcome to The Explainer. I am absolutely thrilled to guide you through one of the most critical foundation-building topics in the Cambridge IGCSE 0625 physics syllabus, pressure from the air. But listen to me carefully. Right from the jump, we are treating this like a marathon. Today's core concept is all about energy management for the long exam hall, pacing yourself. We are not just going to memorize a couple of formulas, cram them into our short-term memory, and hope for the best. No, we are going to master air pressure using concept-first, first principles thinking. We want to understand the underlying how and the exact why so deeply that no matter what kind of weird, unfamiliar curveball the Cambridge examiners throw at you, you have the exact analytical tools to break it down, step by step. We're going to build a system today that protects your marks and saves your mental energy during those grueling exam papers. So get yourselves ready, clear your desks, focus up, and let's fundamentally shift the way you think about forces, pressure, and exam strategy. Here is our strategic roadmap for today. We'll start by looking at the pressure challenge, move right into our four-step core framework, then examine some real-world applications, learn how to avoid exam traps, and finally wrap the whole thing up with a quick recall checklist. Section 1, the pressure challenge. Okay, let's dive right into this. What physical effect, measurement, or prediction actually depends on understanding pressure from the air? I want you to really think about it. Right now, as you're sitting there, the weight of a small car made entirely of air is pressing down on your shoulders, literally. Why don't you notice it? Why does a sealed metal can suddenly crush inward violently when the air inside it cools down? Or on a biological level, how do your lungs actually manage to draw in a breath? Before we even look at the formal physics language, we have to anchor this concept in reality. Now let me introduce you to two types of students I see in the exam hall all the time. Let's call them Alex and Sam. When faced with a question about a crushing can, Alex just overloads the page with raw physics facts. Alex writes down everything he knows about air, particles, and temperature, completely ignoring the specific command words in the question, zero analysis. Then there's Sam. Sam gets nervous about the clock, rushes the answer, and writes down one panicked sentence that totally misses the command word requirements. Both of them lose massive marks because they don't have a strategy for the physical effects. Before we continue and fix Alex and Sam's mistakes, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. The secret to beating the exam is this. You must master first principles reasoning instead of relying on memorized textbook wording. Alex's trap is thinking that just reciting words is enough. It's not. The examiners are specifically testing your ability to reason. When you use first principles thinking, you aren't just regurgitating a paragraph. You're actually thinking like a physicist. You're looking at the fundamental truths, particles moving, particles colliding, and building up from there. This makes you incredibly resilient. It makes you highly capable of reasoning your way through completely unfamiliar exam contexts, whether they ask about a balloon, a syringe, or a deep sea bell. Let's move to Section 2, the four-step core framework. This is where we completely change the game. Pay very close attention here because this is the strategy reveal. The anatomy of a top-tier maximum mark exam answer perfectly maps out into these four exact steps. Think of this as your Peel framework: point, evidence, explanation, link, but specifically weaponized for Cambridge physics. Step 1. Identify the quantity or phenomenon. That's your point. What are we actually talking about? Pressure. Step 2. State the relationship involved. That's your evidence. How do the variables interact? Step 3. Explain the underlying physics. This is your explanation and it is absolutely crucial. This is where you talk about the microscopic world. And finally, Step 4. Connect it to a real-world observation or experiment. That is your link. Top students structure every single descriptive physics answer using this exact blueprint. If you rush like Sam and skip any of these steps, you are quite literally leaving free marks on the table for no reason. This four-step framework works so flawlessly because it completely relies on a concept-first pedagogical path. It acts as a translation device. In your head, you move gradually from everyday language to precise physics vocabulary. Let's do a live transformation right now. Imagine your initial thought is, the air pushes on the walls of the box. That's everyday language. It's fine for a chat, but it gets 0 marks in 0625. So we upgrade it. We zoom in. We say air molecules are in constant random motion. Then we build on it. These molecules collide with the inner walls of the box. Then we apply the physics. Each collision exerts a tiny force, and the total force spread over the area of the walls creates pressure. Boom! You just turned a red pen mark into a massive green check mark. That is the physics success blueprint in action. I want to burn this quote into your memory because it essentially unlocks the entire syllabus for you. If the topic involves fields, forces, particles, insist on cause and effect rather than isolated facts. Whether you're looking at complex data tables, graphs, or particle diagrams, you have to relentlessly focus on the why and the how. You need that unbroken chain. Particles move, therefore they collide, therefore they exert a force, therefore force over area equals pressure. That logical cause and effect sequence will stick in your mind forever, unlike isolated facts that vanish the second you sit down in the exam hall. Let's transition into Section 3, Real-World Applications. Where does this actually matter? Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at the bigger picture. This micro topic of air pressure isn't just an isolated chapter you learn once and forget. It acts as a massive gateway into global industries and scientific patterns. Pressure from the air is the invisible hand behind standard lab experiments. It dictates the rigorous engineering behind safety in transport, like the pressure differentials that keep airplanes flying safely at 30,000 feet. It is the core mechanic behind medical technology, and it even plays a role in how we understand atmospheric conditions in astronomy. This is real, tangible science. So the crucial point for your exam strategy is this: connection. Linking the invisible, theoretical physics, like atomic particle motion, to a real-world device is the ultimate proof to the examiner that you actually know your stuff. You must always be prepared to name at least one real situation and explain exactly why the physics helps us predict the outcomes. Think about a medical syringe. When you pull the plunger back, you increase the volume inside, which decreases the collision rate of particles, which lowers the internal pressure. The higher atmospheric pressure outside then pushes the liquid up into the syringe. That is a perfect logical prediction based on physics. Moving right along to Section 4, avoiding exam traps. Let's fix those lost marks. Let's do a quick find the flaw challenge. Look at this comparison. On the left, we have a massive exam weakness. A student simply writes down the correct formula, P equals F over A, but provides absolutely no explanation of the variables. They just quote the math. The examiner gives them maybe 1 mark if they're lucky. On the right, we have the safest method. This brilliantly illustrates the difference between a weak answer and a top-tier answer. The safe method defines pressure, states the relationship, explains the underlying physics of the colliding particles, and applies it. It proves you understand the physical effects, not just the algebra. Here's another trap. Never, ever just drop a random example onto the page without linking it to the physics. If the question asks about atmospheric pressure and you just write, like a suction cup, and move on, you failed the question. That is the exam weakness on the left. You must explicitly build the cause and effect chain. So let's do some speed writing in our heads right now. 30 seconds on the clock. How do you explain the suction cup? You write, pushing the cup expels air, creating a vacuum. Fewer air particles inside means fewer collisions, resulting in lower internal pressure. The greater atmospheric pressure outside exerts a larger inward force, holding the cup in place. That clear chain is exactly what examiners are desperately looking for. Finally, Section 5, Quick Recall Checklist. Let's build your ultimate revision tool. This is your final bulletproof system. These are the rules that guarantee top marks. Decoding the command word, applying the 4-step framework, and using a time management matrix so you don't end up like Sam. Whenever you are revising pressure from the air, I want you to run through these 4 specific prompts. Number 1, what is the core idea? Number 2, what changes physically at the particle level? Number 3, what quantity, formula, or graph shows this relationship? And number 4, where is it used in the real world? If you can sit down at your desk, close your book, and answer these 4 prompts out loud, clearly, and confidently, then your knowledge is incredibly secure for both short answer and long structured questions. I am going to leave you with this final provocative thought. But before I do, listen to me closely. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Now, your challenge. Give one real-life example where pressure from the air matters and justify the link clearly. Don't just think about it, do it. Drop a comment below with your target grade for physics and the biggest challenge you're facing.
Our team responds to every comment. Like and share this explainer with a study partner. Ace the exams. Your Cambridge success starts here. Keep questioning the physical world around you, manage your exam energy like a marathon runner, and I will see you next time.